Hello and welcome to another episode of the Geotechnical Engineering Podcast, a podcast focused on helping geotechnical engineers stay up to date with technical trends in the field. I'm your host, Jared Green, and I've practiced as a geotechnical engineer for over 18 years. And in addition to practicing engineering, I enjoy mentoring young engineers and first-generation college students. I've focused on helping to increase the number of pre-college students that are interested in STEAM majors and fields. By STEAM, that's science, technology, engineering, art, and mathematics. In this episode of the Geotechnical Engineering Podcast, I'll be talking with John Peirce Jr., PE, D.GE, founder and principal of Peirce Engineering. We'll be talking about the importance of mentoring young engineers, the need for field experience before becoming a design engineer, and continuing education. I believe this episode can help you with some of your career planning efforts. With over 50 years of design, build, civil, geostructural, and construction engineering experience, John Peirce is well equipped to provide to his clients a wide range of engineering services needed for their building, highway, bridge, and marine project. Besides being a founder, owner, and officer of Peirce Engineering since 1992, John's responsibilities include engineering design of various types of structures for both his contractor clients and for other engineering firms. Mr. Peirce's combination of construction and engineering experience has enabled him to provide his clients with several thousand safe, successful, and economical designs. In addition to his design duties, he is responsible for mentoring and training the firm's engineers and for providing quality control and review for all of their engineering work. Mr. Peirce is also a life member and past president and board member of the American Society of Highway Engineers, ASHE, as well as many other professional associations. And with that, let's jump right into our conversation with John Peirce Jr. Hello and welcome to another episode of the Geotechnical Engineering Podcast. John, it's good to have you here. I already introduced you to our listeners, but how you doing? How you feeling?
I'm doing
today?
great, Jared. Good to see you again.
Excellent. It's good to see you. I love the background. Looks like you're already in the hole here.
Oh yeah, I didn't know which picture to put up there. I have hundreds and hundreds and hundreds of job photos. You can't have enough good job photos to show people what you're doing.
Exactly.
Very important.
Especially as a geotechnical engineer, right?
Yes. All our work gets covered up. Nobody
Yeah.
sees it. How tall is that building? Who cares? You want to know how deep it is? I'll tell you.
Exactly. All right. Well, if you could, in your own words, can you tell us a little bit more about what you do on a daily basis? A lot of our listeners, they may have heard of your firm, heard of you, but let them know, what is it that you do? What's it look like, John?
Okay. Well, on a daily basis, well, when I started out, I did everything. I was a one-man band. I did the billings, I did estimating, I did, design, whatever. Then Jennifer came to work with me. I turned over a lot of that to her. So now, she basically runs the office. My son John does engineering with me. So that leaves me free to do some of the crazier engineering while they pretty much, run the business part of it. So it lets me have plenty of time to do crazier designs, teach them some of the crazier things that they've done or that they need to do. And, keeps me busy, keeps me just doing what I like to do best, and that's doing the engineering. There's so many different types of designs and construction I've done over the years that, honestly, I don't even think my daughter and my son have really been exposed to it all at this point in time. But, they're getting there slowly but slowly. And they've been with me, I think, something like, 15 and 26 years respectively. And they still haven't done a lot of the things that I've done, but they're getting there.
Okay. All in due time, right?
Right. So, basically what do we do? We get calls from mostly contractors, sometimes other engineering firms, sometimes architects, developers, to really determine what they need for a job. We come up with a design for them, give them a price to design it. And then if they don't necessarily know how to build it, we help them get the expertise to figure out how to get the job done. So pretty much my days are spent doing design, giving people some prices for things, and also then really keeping an eye on what my son and daughter are doing, mentoring them, and peer reviewing their design. So basically, I'm the bottleneck in the company because a lot of things that they get done still have to go through me, and that's a little bit tough sometimes when I'm still trying to do my own design. So I apologize if I'm holding you up, anybody that's listening, but I am the bottleneck.
Okay, got it.
But I'm also the quality control.
Excellent, excellent. And when you say design, mostly supportive excavation, temporary supportive excavation design, or are there other things as well? Or?
Mostly supportive excavation, temporary and permanent walls, tied back walls, braced walls, steel sheet piling. We do a lot of cofferdam work. We do underpinning, soil nailing. We've done, I don't know, probably 150 temporary bridges with Acro Corporation, temporary panel truss bridges. We do a lot of different stuff. Not so much anymore, but we've designed concrete forms for contractors. We do design some piles for people. We don't go out of our way looking for that kind of work, but we do some pile design. We've done some caisson design on smaller scale. We try not to do what the big people do very well and probably more cheaply. So we some of those different things we get involved with are on sort of minor basis, but we do dabble in a few of those things.
Excellent.
So we would keep busy.
And did you always know that you wanted to start your own firm? When you were starting out as an engineer, did you always know you wanted to do this?
Oh, I never figured I would have my own firm. When I was young, I knew that I wanted to be in construction. I knew that I wanted to be outside. I didn't want to be in an office. Well, look where I am. So then I knew I wanted to be an engineer. So I, went to Drexel and did that. And eventually, I did work my way into the office, but I spent a lot of years outside in the field. Everything that I design, I personally have built. I've worked for the water department doing surveying, starting back when I was a co-op student. Then I worked, several co-ops for a heavy and highway contractor. I've worked on, bridges, sewage treatment plants, utility projects. I've been a foreman. I've been a surveyor. I've been a project engineer. I've been a design engineer. I've been a project manager. So like I said, I've done, pile foundations. I've done, concrete work, concrete form work design. I've done a lot of different things, which I'm sure there aren't a whole lot of people that can say that they've done as many things as I've done for as long a time.
That's awesome. And I understand you have a understanding that engineering education begins after graduation. It's a very interesting way of thinking about it. Can you tell us more about what you mean by that?
Yeah, I greatly believe that. College provides limited hours of instruction. Usually it's the basics, the tip of the iceberg, but there's a whole lot more to be learned than what you have in college. College leaves, little time for learning real world engineering. I remember when I was in college and I asked Dr. Bob Kerner, who's, internationally known. At the time, he was probably my main and favorite college professor. This was in his geosynthetics days. So he was basically teaching, all the different types of soil mechanics and geotechnical engineering and foundation engineering, that things, the stuff that really interests me. I'm not really too into geosynthetics. But anyway, and I remember asking him,
our little secret.
I remember asking Dr. Kerner, where can I learn more of this stuff? Are there any, colleges, or any places where I can get courses in all this stuff that I'm interested in, all this geostructural work? And he basically told me that there really wasn't. You had to kind of learn it on your own. And that's what I've done over time. I had a couple early on mentors that taught me like at least they aimed me in the right direction. I don't know how much I really learned from them, but they aimed me in the right direction. They encouraged me. And little by little, working on a lot of jobs for some really good companies, I learned more and more. In addition, you gotta do a little bit of learning on your own. You gotta, accumulate the right reference books. You gotta read them, uh, talk to people, find people that do things that you haven't done yet. Uh, there's a lot to be learned after you get out. And in college, you're learning some of these basics. You don't always follow through with all the, designing down to the nuts and bolts of a project. You got to learn all that when you get out of school, especially if you're in geotechnical concentration in school, and now you're going to be doing geostructural work. You may be a little weak in the structural part, so you got to start picking that up on your own out in the field, or in the office working for somebody else, or take some additional courses, take your master's degree, keep going. So, I think I've learned a tremendous amount more of what I do since I graduated. Yeah, you need the basics, but you really got to learn some more on your own when you get out.
Like, absolutely right. And, it's one of those things where you continue to learn. And if you think that once you get your degree and cross that stage, you're finished learning, that's not really what you sign up for as an engineer,
Right.
especially as a geotech.
Right. What you learn in college really depends on your professor's experiences. The better professors, they have real world experience. They're more engaging. The experienced professors who have, industry experience, they instill confidence in the students. They, you can see that they've been there, they've done that. And like I said, I, mentioned, Dr. Kerner again. He wound up years ago working for the same company that I wound up working for. So we wound up working with the same people, knew the same people. I could relate to that because while he was still teaching me in college, I was co-oping for that company. So we had a bond right there. It really worked out nice. It made me feel good in what I was doing. He had been there and I was following him.
Awesome. Awesome. And you mentioned mentors, at the Engineering Management Institute, really strong believers in having a mentor, especially when you talk about growing your engineering career. What are some of the things, in your opinion, that you have to consider when you're choosing a mentor? Like, where does somebody start?
Probably most people wouldn't say this as the first thing that you're looking for, but I think the first thing that you have to look for in a mentor is ethics.
Mm.
Uh, I've worked for, many clients with all kinds of people, and the ones without ethics really stand out. So if you're going to wind up learning something from somebody, it better be somebody that has ethics.
Yeah.
Because when it's all said and done, you have to go home at night and sleep well. You got to do what's right. And there are too many people around that ethics isn't at the top of their priority list. So ethics to me is important for a mentor. Obviously, a mentor has to have really good experiences. You could have the best, PhD professor in school, but if he hasn't done something, I don't know how much you really can learn. You'll learn the basics from the book, but you won't learn the rest of what you really need to learn. So a mentor has to really have good experience. The mentor, I believe, needs to be well respected by others, both inside and outside of, your own company. If you're learning from somebody who's not well thought of and is not considered to be an expert or knowledgeable in the field, there's a good chance that person isn't. So you can tell when you're working for somebody how well they're respected. And to me, it's important that a mentor be respected by others. The mentor also has to show an openness and willingness to share that knowledge.
Mhm.
Not all, higher up senior type people are willing to share that knowledge. A mentor has to be confident enough to not look at the younger engineer as being a competitor. They got to share something with you. They know that you're going to, you're going to take their place at some point in time. It happens to all of us. Yeah, the mentor has to have enough confidence to not look at you as competition. The mentor must believe that the younger engineer is or will be a valuable team member. Has to have faith in that young engineer. Otherwise, the mentor is really not going to get through to the engineer, and there's not going to be a proper transfer of knowledge. Now, that being said, what a young engineer does with that shared knowledge is important. The younger engineer has to question what the mentor is trying to transfer. The younger engineer has to then make sure they use it and remember it. Because, you will always need that information again and again. It's amazing how often in your career you'll wind up doing the same thing over and over. It might be a little bit more difficult, a little bit different somehow or another, but you can always keep building on what you learn. So whatever you learn, you got to question it, use it, remember it. It'll come back. You'll see it again. And mentoring is one of the reasons why I decided to teach a course at Villanova in what I do in foundation engineering. I just thought it was important to try to give back to the younger people some of the things that I've learned. If I can make it a little bit easier for them to learn something or learn it a little bit quicker, it was worth my time and effort.
Excellent. Excellent. No, that's great. That is great. And when I think about mentorship, and you hinted at it, there has to be an openness, both sides. There has to be a trust, both sides. But communication is like so important. And perhaps it's not stressed enough when we're in school, but the way we communicate with people says a lot about us. And even when you're not saying something, even when you're not using a word, you're still communicating. Why do you think it's important for engineers to speak less and listen more? I've heard you say that before.
Well, I've seen too many coworkers, some of them engineers, not listen closely to higher ups when they're receiving instructions. These people, they weren't listening well. They didn't understand what they were told, but they were afraid to say so. And when they did not properly perform the required task, stuff happens. They get in trouble. They get ostracized a little bit sometimes. They get given menial tasks to do. When I was young and relatively new, it was important to me to know exactly what I was being asked to do. If I didn't understand what I was being told or asked to do, I said so, and I asked for clarifications. This prevented many problems and prevented me from having to do things, more than once. You don't look too good to your bosses when you screw up and you have to do things more than once. So to me, it was, don't be afraid to ask questions and say you don't understand. Now, getting back to the part about listening and not talking, I worked closely under a very smart and experienced company vice president, early in my career. If a problem or a situation arose that was beyond his experience, he said little at that minute or at that moment. And then, as soon as possible, he did his homework. He called other people that he knew that had handled similar situations, and picked their brains. He did his homework so that when he did speak or make a decision, he knew what he needed to know to make an intelligent decision. He listened, he learned before he spoke. On the other hand, I worked for another individual who didn't know, didn't listen, didn't learn, but he spoke anyway. It was obvious to all involved that he didn't really know what he was doing. If you don't know something, don't be afraid to ask, do your learning, and then be prepared to talk. If you don't do that, speaking without knowing, it's a recipe for disaster. Abraham Lincoln said, better to remain silent and be thought a fool than to speak out and remove all doubt. Learn, make sure you have something important to say, and then don't hesitate to speak up. I believe it's very important to listen and learn before speaking.
Well said. Well said. Those are definitely some truisms there, John. And I know you said that engineers really need to know how a structure is built before they start designing it. And that seems pretty straightforward, but walk us through that a little bit, because I think that's very important. And I agree with you. It's like very important, but sometimes take it for granted.
Well, you and I agree, but there's a lot of other people that don't necessarily agree. I believe, learning how things are built, getting field experience. It's very, very important. It's critically important. How can you tell someone else how to build something if you yourself don't know how? Uh, with Peirce Engineering, we average doing a couple projects a week. We see many, many plans and designs from other engineers. Uh, Too many of these designs, for geostructures they're uneconomical, they're unbuildable, they're unsafe. Yet somebody paid them good money to come up with this design. Uh, like I said, it may not be buildable, may be unsafe. It's obvious when a design engineer has little or no experience with a particular geostructure. Uh, you really got to get your feet wet. You shouldn't be allowed to design anything unless you really know how it's built. Bad plans, bad specifications, incorrect, unreasonable review comments on submitted designs. They all are the result of people that really don't have field experience. They don't really know how to build things. They want you to do things that are wrong, unusual, uneconomical. Inexperienced engineers, they cost owners lots of money and can cause serious safety issues. Like I said before, everything that I design, I've built, and it gives me a leg up over most of the engineers that I'm dealing with. We just about everything that we design has to be reviewed by the owner's engineer, whether it's like PennDOT or some other large engineering firm. And it's really hard when you have some really crazy questions or comments from reviewers that really show their lack of experience. Uh, I guess that's a mentoring experience for me. Then I have to go back and really explain what I'm doing, show the people where this information comes from, show them that what is normally done, give them the references. Basically, you got to try to educate some of these people that don't have that experience. Sometimes it works out great. Sometimes it just makes the situation worse.
Got it. And when you're talking about experience, we talked about this a little bit earlier, but how does an engineer know what the limitations of their experience are? Like how does somebody know that?
Well, in my opinion and my experience, there are far too many engineers who don't know their own limits. It's unethical for engineers to perform services in which they are not competent, but it happens every day. Too many engineers do not know, or they don't care, that they are practicing in areas beyond their competence or experience. They won't hesitate to pick up, one textbook someplace that says, do something this way. And then they just plow on ahead, figuring that they have all the information they need to know to design this structure. Too many engineers do not know what they don't know. It's important to know stuff. It's important to know what you don't know so that you can then, stay away from the areas that you're not really competent in. Uh, Too many engineers accept work for which they are not qualified to perform. Uh, people, people call engineers thinking every engineer knows everything. That's not true. Engineers have specialties. If you have a special problem, you better find an engineer that has engineering experience in that special problem. Uh, Engineers, they just hate to turn down work. They hate to turn down billable hours. They say, oh yeah, we can do it. Frequently they can't or they shouldn't, but they do. Too many. They just don't know that they should be referring work outside of their experience to other engineers that are more qualified that have done it. I get plenty of calls from clients that want me to do this or do that. And frequently I'll say, I can do that for you. Probably not as economical as fast as somebody else. Go to that person. I recommend that you hire this person. Or somebody will ask me for something and I may be relatively knowledgeable about something, conversant in it, but I would not consider myself an expert in it, or maybe not the best person for that particular project. I'll refer my client to another engineer who will be able to, solve their problem probably more quickly and more cheaply. The person that calls me up and the other engineer who I, give the referral for, they'll appreciate that referral. More likely than not, the first person that called me will remember me, and we'll get together later on another project that's more appropriate for what I do. Happens all the time. I try not to bite off something that I can't chew. I try to do what's best for the client, try to give him a fast economical solution, whether it involves me or not. They'll remember it. They'll appreciate it.
You're absolutely right. And that ties back to the ethics again. If you know this is not
Yes.
something that you do, and that's why it's good to have a network and know who does what, give this person a call. And people are not going to forget that, you understood your limitations. I can't do that, but I can do this. So the next
Yes.
time it comes around, you're still getting that call. So that's like super.
I look at my major function as being a problem solver at Peirce Engineering. I help people solve problems that they don't know how to get out of. If I can solve it personally, I will. If I have to hook them up with the other right person, that's what I do.
It's important. I remember as a young engineer, and you get to the point where you've been in school, you've been in grad school, and now you're working on the site, your construction site, and then you get to a team meeting. You look around. It's before COVID, of course. You look around the table. You say, "Wow, it takes all these people to build something," right? So it's like there's a lot of experts. So
Yeah.
you shouldn't feel pressured to think that you have to figure it all out.
Mm-hmm.
All right, great. Well, before we go to our break, another thing that's like very important for practicing engineers is just the concept of continuing education. And as the engineering disciplines become more specialized, continuing education becomes more crucial, right, for managing your career and growing your career. How would you say the engineers can remain diligent in keeping up with their continuing education?
Well, first, I'd like to say that continuing education is critically important. The world's changing, so fast that, new methods and structures, new techniques, new equipment, even new educational courses, these are required. However, a little bit of blasphemy here. I am not a favor of mandatory continuing education. In my opinion, the current continuing education system is inefficient, arbitrary, and too confusing. There are too many PE boards, too many different requirements, too many bad continuing education courses and meetings, too many bad continuing education providers who are maybe just in it just for the income. But there are many good providers, but there are too many bad ones. I believe that the cream will rise to the top. The bad engineers will eventually be left behind. The good ones will get their continuing education one way or the other. They'll either go to good providers to get it, they'll go to bad providers to get it, or they'll self-teach it. I myself, I hate to say it, but for a lot of what I do is basically self-taught. You got to make an effort. You got to get the right reference books. You got to read them. Good engineers will get the continuing education needed, whether it's mandatory or not, whether it's organized courses or whether it's self-learning. Engineering disciplines are becoming, much more specialized. New techniques and equipment constantly are being introduced from all over the world. These techniques need to be properly communicated, so that they are properly implemented. You really have to do that. You got to make an effort to do it. But you got to be careful about, where you're going to get these continuing education credits. A lot of them are fluff, just to help meet, quotas of how many hours you need per year. And I wish the system were a little bit better, but unfortunately it's not. I wish continuing education was more of a centralized situation where a certain body has similar rules for everybody. But I don't foresee that happening for a long time. Nobody wants to give up control of continuing education. None of the PE boards or the states want to do that. So that's my rant on continuing education. It's very critical, very important, again, but it is possible to do it on your own.
Yeah. And I like what you're saying as far as, being critical about the content that you're consuming. I mean, our time is fruitful, right? So if you see a topic that's giving PDHs, professional development hours, but it's not something that's tied to what you do, and it's not something that's of interest to you, and you don't think you're going to gain anything, it could be a waste of time. It could be a proverbial waste of time compared
Yeah.
to doing something that's tied more along the lines of what it is that you do. So it definitely very important. And you're right, there are multiple different ways to do it. As far as self-study, that's another thing that can be considered depending on which state you're practicing in. So good stuff there. Good stuff there. So right now we're going to pause for a moment, and then we're going to come right back in just a minute and close this one out with John and our career factor safety end segment. Stick around. All right, welcome back. It's time for our career factor of safety end segment. In geotechnical engineering, like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're talking with John Peirce Jr., PE, D.GE. John, you've already had a very successful career. And when you look back at your career, what's one thing you implemented into your career to give yourself, let's say, a factor of safety in your career?
Well, I would think what gave me the biggest factor of safety in my career and kept me busy, very, very busy for constantly for almost 50 years now, is basically having more than one specialty. Um, you know, I've had, a lot of experience with the geostructures. I've had, experience at designing, concrete formworks and, you know, building things, piles, cofferdams, all these different things. And by having a number of these different specialties, there's a good chance that somebody's going to need them. Uh, you gotta be flexible in doing these types of different work jobs. Uh, I've been very lucky over the years that I've been able to work in the highway industry. I've been able to work in building construction, marine construction, utility construction, water resource type construction. And not all these areas are slow at the same time.
Mm.
So if if you're experienced in several of these areas, there's a good chance that you're always going to have work. When the economy slows down, the government's kicked money into the highway industry. So we keep working in the highway industry until the buildings start up. Sometimes the DOTs run out of money and it gets slow and their projects get shelved or postponed. Maybe the building industry is booming. Maybe it's the marine industry. So I've been pretty lucky that I've got specialties that can be applied to these different areas of construction. So I can honestly say that in all that the 20, whatever it is, 28 years, almost 29 years now that I've been with, Peirce Engineering, we have never been slow. We've always managed to keep busy. If we've been slow, it's been like for a week or so. And then we start worrying, and then all of a sudden the floodgates open up. So it helps to have specialties that can be applied to these different areas, and it helps to be well known. The people just call us. A lot of repeat business from previously satisfied customers, and we can jump from one area to another and apply these specialties that we're experienced in. So that's been the biggest thing that's kept us working.
Excellent. Excellent. John, thank you so much for coming on, and thank you for sharing all the great insights that you shared. And I know there's great information here. There's going to be good advice and really helpful for our listeners. If a listener is, listening to this or viewing this and wants to reach out to you, what's the best way for them to find you? Any social media or email you want to share?
Well, probably one of the best ways is just find us at our website. First of all, that'll have contact information. That's www.peirceengineering.com. Make sure you spell Peirce Peirce. There's another Pie Peirce, but he's designs guns or something like that in Wisconsin or someplace. But so www.peirceengineering.com, or email just jpeirce@peirceengineering.com. Pretty easy to get a hold of.
Excellent. Thank you so much for coming on. This is great. This is great.
I enjoyed it. Thanks a lot, Jared. See you at the next meeting.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode 22, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the best in all your geotechnical engineering endeavors. Peace.